Welcome to my YouTube channel. It's your number one tutor on this channel, the Science Demystifier. In today's video, we're going to be looking at the salt analysis. The salt analysis involving zinc chloride and a solution of powdered milk. So this is in line with the forthcoming Neco chemistry practicals. So I want us to pay attention to the details I want to give in this video. Now already I have at the board the observation table. So my observation table is always tentative. So if you've been following me on this channel and you've been following my videos, you've been watching my videos, you will observe that I'm always tentative in my descriptions. So we're going to be looking at the expected questions or questions that might likely come out in this forthcoming Neco chemistry practicals. Before we go to the observation table, I will first of all carry out the analysis of the specimen or the salt specimen that came out this year, and that is zinc chloride and a solution of powdered milk. I'll be back shortly. So welcome back. Based on the salt specimen that came out and the reagents that we were asked to provide for the students, please, I want to give this instruction to students and also teachers, chemistry teachers out there. Please, we are working together to achieve a collective goal. And what's our collective goal? Is just to ensure that these students, they do well in their exams, to properly guide them to do the right thing. The analysis of zinc chloride and a solution of powdered milk is what I'm going to do now, and it will guide us into the proper thing. Okay, so please don't forget, if you have not subscribed to this channel, if this is the first time you are watching the Science Demystifier live on this channel, please don't forget to subscribe to this channel. Please, it doesn't remove anything from you. Just hit the subscribe button so that we grow collectively, we grow together. So our aim is to make sure that we guide people out there to do the right thing. Okay, so just hit the subscribe button to subscribe to this channel. Now let's go to the specimen, the salt specimen that came out as zinc chloride and a solution of powdered milk. Okay, this is very, very simple. That zinc chloride is a polar compound which we know too well that it is soluble in water. Okay, is soluble in water. It dissolves in water to form zinc 2 ion and chloride ion. So a solution of this salt is going to contain zinc ion and chloride ion. A solution of the zinc chloride will contain a cation called zinc ion and chloride ion. So you should be expecting tests on zinc 2 ion, and also you should expect tests on chloride ion. And there are possible ways we can test for the presence of zinc 2 ion using common reagents like aqueous ammonia and sodium hydroxide solution. So we're going to study the chemistry of zinc and these reagents. How does zinc react with sodium hydroxide and aqueous ammonia? Now when you add aqueous ammonia, let us go to the board and see a sample question. So let's go to the board now and see a sample or the observation table. So you can see the observation table here. So this is what we're going to be seeing on that day. Something like this. So it might not be exactly like this, but something like this. 100, let me say not 100%, but about 80 to 90% of what you're going to see that day will come from here. Okay, let's see. We have tests, observation, and inference. So which is always the normal way or the traditional way of preparing our observation table. Then we have C plus 10 cm cube of distilled water. So of course, like I said earlier, since zinc chloride is a polar compound, it's going to dissolve in water. It's going to dissolve. So the observation will be C dissolved completely. C dissolved completely on addition of distilled water. And your inference will be soluble compound present. Soluble compound present. Okay? So let us see the step 2 of this analysis. So the step 2, you will be asked to dissolve the solution obtained from I above, that is this solution of C obtained from the first step. You will be asked to divide it into 3 portions. You will be asked to divide it into 3 portions. So to the first portion, you will be asked to add sodium hydroxide in drops and in excess. You will be asked to add sodium hydroxide in drops and in excess. And when you add sodium hydroxide to a solution of zinc salt or lead salt or aluminum salt in drops, you will get a white gelatinous precipitate. You will obtain a white gelatinous precipitate. White gelatinous precipitate. So your inference or your conclusion will be the suspicion of these 3 ions, which is lead 2 ion, zinc 2 ion, and aluminum 3 ion. Now, when you add the sodium hydroxide in excess, the PPT is going to dissolve because these 3 ions, they form their salts dissolve in excess sodium hydroxide solution. Why, if you may ask? Is because of the amphoteric nature. The amphoteric nature of these metals. They are amphoteric in nature. So that's why they dissolve both in acidic and alkaline mediums. Okay, now let's go to question number 3 here. Question number 3 here, or the instruction number 3 here given says, to the second portion of the solution obtained from C, add aqueous ammonia. I hope you can see clearly. Add aqueous ammonia in drops and then in excess. Add aqueous ammonia in drops and then in excess. Okay, so our observation will be a white gelatinous precipitate formed. So the PPT is going to dissolve on addition of excess of the solution. That's when you add the excess of aqueous ammonia, the PPT will dissolve. Okay, and when the PPT dissolves, that's the confirmatory test for zinc 2 ion. That's the confirmatory test for zinc 2 ion. Meanwhile, when you added the drops and you got a white precipitate, you are going to suspect aluminium and zinc. You're going to suspect aluminium here and zinc in the solution because the 2 of them will form white precipitate on addition of aqueous ammonia. Okay, now let's go to the remaining parts of the observation table and see what we have there. Now, I don't know whether you can see clearly from that point. So, number 4 says, third portion of solution from C plus dilute HNO3, then followed by addition of aqueous silver triazonitrate solution. When you add your acid, there will be no visible reaction. There will be no visible reaction, but when you add silver nitrate to the resultant solution, you're going to have a white cloudy precipitate. You're going to have a white cloudy precipitate. I hope you can see it clearly. Then your conclusion will be chloride ion, which is Cl minus confirmed. Chloride ion, which is Cl minus confirmed. Can you see? So we're going to say chloride ion confirmed. Okay, now let's look at the last part of the observation table. So here we are asked to add D to sodium hydroxide. D is a solution of powdered milk, and we know that one of the nutrients we get from powdered milk is protein. So there's protein. So definitely what they're testing for is proteins. Now we have different ways of testing for the presence of proteins in the laboratory. We have the one used in millions reagents. We have the proteic tests. We have also the burette test. I believe that based on the reagents that we asked to supply to the students, I was able to predict that it is the burette test they want to carry out, the one that is coming out. So the burette test has to do with adding a solution of sodium hydroxide followed by the addition of aqueous copper 2 sulfate. Okay? So when you add, the solution is going to be colored purple. And once you see that, that confirms that protein is present in the solution. So that is the summary of the salt analysis for this year's Neco chemistry practicals. Please, if you have any question to ask, if you have any comments, please do that in the comment section. I will attend to you. So thank you. See you in my next video when I'm going to do my analysis on not analysis anyway, but it's going to be volumetric, not salt analysis, but it's going to be volumetric analysis. Volumetric analysis, that's titration involving H2SO4 and sodium trioxocarbonate 4. So thanks for watching. See you in my next video. God bless you.